Hello friends, welcome to our channel Mirror Neuron, which means watch and learn. And in our last class we have seen that how a feed forward network is implemented in Python, and we have also initiated our model parameters, which was beta 1, beta 2 and the bias with some random value, and then we have calculated the summation, and then we passed that summation to an activation function, which was our sigmoid, and we got the output. Of course all those outputs were wrong, but then it gave us some value. So in our lecture today, we are going to look into something called as the backward propagation. And before we actually can implement a backpropagation algorithm, first we need to understand the basis, that why do we need to do so, right? Okay, so first thing we'll start with is the error function. So if you are already familiar with machine learning projects, you have already implemented so many error function in your projects, but then I will just repeat it for somebody who is still not familiar probably. So error function is nothing but the difference between our original value and what we have predicted. Okay, let me give you a very simple example. For example, say your grandma makes a very tasty cupcake, right? And next time you say that, okay grandma, this time I'm gonna make cupcake for you. So what you try to do is say, for example, you are making say 5 cupcakes, and you are supposed to put actually 5 spoon of sugar, all right? And but when you were preparing the cupcake, because you say you don't know what was the actual number of a spoon of sugar you are supposed to use. Say you tried with say 2 spoons, and you made the cupcake, and then when you tried to eat it, you found that it was not sweet at all, right? Because 5 cakes, say suppose, needs 5 spoon of sugar. So what you do, you go back to your grandma and you tell that, hey, am I making some mistake? So your grandma says that, yes, there are less sugar, so you need to put more sugar. So you go back, you start your recipe all over again, and then this time what you do, you try to put 3 spoons of sugar, and you make your cupcake, and you eat it, and you realize, okay, it's still not tasty yet. You try again, you go back to your grandma, she says no, we need more sugar. You come back, you put this time 4 spoon of sugars, you taste it, you see it starts getting better, but it's still not up to the mark, right? Now what happens, you go back again and you get the review from your grandma, and then now this time you put 5 tablespoon of sugar, and it tastes really good. So but you don't know yet, right? So what you do, of course you can go back to your grandma, and you can tell this, and she can confirm it, but then probably she doesn't remember, say for example, whether she put 5 spoon or 6 spoons. So what you do, you put another teaspoon of sugar, and then you realize, okay, now it has become more sweet than it was required. So what happens is, at one point of time, you are exactly matching your grandma's recipe, and before you used 5 tablespoons, you were making some error, and when you went beyond your 5 tablespoons of sugar and you put 6 spoons, you again started making some more mistake, right? This is exactly like getting a feedback, right? And this is what is called as the error function, that how much wrong are we when we are trying to predict something. In this case it was just the number of tablespoon of sugar, but in real world also we will use this kind of feedback mechanism, and that feedback mechanism in this case is what we are going to call it as back propagation. So basically we are going to continuously compare it with our original value and try to reduce that error. That is the main fundamental behind it. Now in our case we are using this mean squared error, which is nothing but the original value minus the predicted value whole square. We'll discuss about why we are taking a square and then we are trying to average it, but for the time being, in our previous lecture we saw that all our results were very close to 1, right? So that means if my x1 and x2 are this combination of values, my y true, which I already know about it, they are 0, 0, 0 and 1, and the predicted value in my case are all 1s, I can see that my y true minus y pred whole square is basically 1, 1, 1 and 0, because I'm pretty close to the original output in the 4th case. So my total error is 3. which makes sense, right? Because I made mistakes in 3 cases and I was only correct in one of the cases. So that is my total error. Now my main intention is to reduce this total error, hopefully, and I want to, in the ideal situation, I want that total error to be actually 0 in this case. So what we are going to do is, I need to understand what exactly should we do so that our error eventually comes down, and that's why I made this small picture. So if you see, my error is actually dependent on this expression called y true minus y pred. Now in this term y true minus y pred, I cannot do much about the y true because that's the data that I've already received. That's the original golden source, I should say. I cannot do much about it. So the thing that I can influence is my y predicted. Now my y predicted was created or generated out of the sigmoid function which ran on my summation value, right? Now I cannot do much about the sigmoid because the sigmoid itself is dependent on the summation, and we know that the summation was dependent on x1.b1 plus x2.beta2 plus bias, right? Now here I cannot do much about the x1 and x2, right, because these are the original input data. So the only thing that I'm left with is my b1 and b2 and the bias. So that means if I can somehow modify my b1, b2 and the bias term, and if I trace this path all the way back, so that means if I change b1, b2 bias, then I'm going to actually change my x1.b1 plus x2.b2 plus bias. Then I'm going to change that summation overall, and then I'm going to change the sigmoid, the value that is passed on to the sigmoid, which will eventually change my y prediction, which will eventually change my y true minus y pred, which is the error, and I will monitor whether it is reducing my error or not. If it is not reducing, then we will further try with new values and then keep trying until this entire process keeps repeating and reduces my error to an acceptable value. That's it. I mean, this is all we actually do in machine learning, and even that's the same thing we are going to do using neural networks. We're just trying to improve our error, and in our next lecture we are going to see the mathematics which is required to make this journey, and then we will also see how to implement that in Python. So I hope you are able to wrap your head around it and give it a try again. Think about it. It will make total sense. It's very straightforward. And thanks for watching, and please subscribe to our channel and press the like button. Thank you and have a nice weekend.